Lovely. Bismillah. Okay folks, sorry we had a battery failure then. This is video number 4. Okay, Isa's tried the second part of the question by changing the plus into a minus. He had a math error. Because on your calculator you have one minus is like this and the other minus is the normal one. Okay. So the naked eye, they both look the same. Do not use that minus, that will give you the math error. That's why I say to you here, the secret of this quadratic equation is being really confident on the calculator. It's not about how easy the method is. You've got to make sure you don't make a mistake how you enter the values in the calculator. So that minus is out, the one with the bracket in it, and which is at the top, and the normal standard minus is in. So please don't use that one, you get math error. And that's the correct one. Once we've done that, we've got a correct answer of minus 0.3874. And we round that off to 3 significant figures. First, second, third significant figure. That's less than 5, so leave it alone. Job done.
That's the actual answer.
That's the answer, yeah. That's the final answer. Come on. Okay, I'm going to rub this off. Isa, you got that down?
Yeah.
Okay, I'm going to rub this off. And I want you to deliver for me, please, the next question. Okay, right. Okay. What's number 23?
Yeah.
Max wants to make a random sample of students from his year group. Explain what is meant by a random sample. Okay. What is meant by a random sample? So each member of the population has, okay, don't come in here, don't come in here. Hey, you've been in the video. No, give me a second. Move out of the way. So each member of the population has an equal chance of being selected. Solid, saying something. Yeah. Okay, we're happy with that. Let's try this new one. Okay, you got that? Yeah. Right, describe a method Max could use to take his random sample. So he's doing for a year group, isn't he? Okay. Okay, describe a method Max could use to take his random sample. So what could Max do? So Max could number each member. Now what year group is he taking off? Is the year 9 or something? Sample of his year group. Yeah. So Max could number each member of his year group. He could then, what could he do then? He could then use the random, okay, you can then use what? The random sampling button, yes? The random select button of this kind. Screen. Okay. Right, are you happy with that, Lisa?
Yeah.
Have you used the random select button on your calculator before?
No.
No? I'll show you in a second. I'll show you. There. Shift random. That one there. That generates numbers. So that would be the first digit is 38. Press it again, gives you another number. That's 60.
Alright.
So it'll be shift. Okay. For those of you who are not familiar with the button that you press on this calculator, you press shift and then you press the button, the point in it, and above it it says okay, and that will give you, like I've got here 0.606, and in the calculator display, so that means you would select, for example, candidate number 60, okay, the first two digits, or candidate number 6 plus 6 if you've got that number. Alright, so use that. Keep on pressing that button until it matches you. Okay, lovely. Right, let's move on. Okay, so really big.
Did you say it's 150?
Okay. Sorry, no, we'll cope. Okay, that's lovely. You can take up just a teeny bit more if you can. That's it. That's right. Just make sure. The table below shows the numbers of students in 5-year groups at a school. Okay, year 9, 10, 11, 12, 13, and the number of students. Lisa takes a stratified sample of 100 students by year group. Work out the number of students from year 9. How many students are there in year 9?
239.
So it's 239 out of the total sample. Can somebody calculate that for me, please? Can you add them up? Okay, folks, can you add that? Isa, can you add that for me, please? Okay, Isa, what number are we in now? 23B, yeah? What do you guys total? What's total, Kismia?
1,140.
That's lovely. 1,140 is lovely. Okay, 1140. Okay, right. Just give me one moment. Paper. Come on, stop running. Okay. Right. So that's the year 9 group. That's the total sample, and that's the stratified sample. Okay? So your selected group divided by the total sample size, and you multiply by the stratified sample size, stratified. So that's what all those things correspond to. Right. Who's got an answer to me for that?
I got 20.9649.
Okay, Samia's got 20.
0.9649122.
Okay, what you got? Isa?
28.96.
96, yeah?
Yeah, 96.
Okay, good. So that gives us an answer 20.96 something. Now, can we pick 20.96 people?
No.
So what should we say the answer is for this question then?
21.
21. So the final answer is 21 students will be the stratified sample for year 9. Okay, right. Lovely. Are you happy with that? Got that done?
Yeah.
Isa? Smia?
Yeah.
Okay. Set up another student. Come on, join us. Nimraz, come on and join us. Okay. Right. Right. Okay. Right. Can we move to the next question, please? Some big fat questions you got there. Do you see one the way? The whole lemon. Up a bit. Tail up. And can you actually reduce the size of gold and minus a bit? And just maybe. That's beautiful. That's beautiful. Just take it off now. Okay, let's just make sure that's also still in the camera view. That's looking nice and clear still. Okay. Okay, we can only record it there. Fine. Right. Okay, Nimra, right. What we're going to do for you, Nimra, let's give you some paper. I don't know whether the paper is at the moment. Huh? Where? Oh. I think here's one. Okay. Right, question number 24. How many questions we got left here? Each side, is that the last question?
No.
We got a few more left?
3 left.
Okay, right. After this paper, we finish inshallah. Prayer break, Asal inshallah. And then we'll come back and do another paper. Okay? Right. A, B, C is a triangle. A, B, and C. A to B is 8.7 centimeters. That's 64 degrees, which is angle C, and angle B is 49 degrees. Okay, in the format of the question, it says angle ABC, which means A to B to C, the angle in between. That's what it's talking about. That's the angle language. Okay, calculate the area of the triangle ABC. Now, if you flip to the front of your papers, folks, flip to the front of your papers, there will be a formula for working out the area of a triangle, which is a non-right angle triangle, and that is area equal half AB sin C. Okay? So this is the formula that we use to work out the area of non-right angle triangles. Working out the area of a right angle triangle is quite straightforward, based on by height divided by 2. This is not a right angle triangle at all, as you can see. Right. So now 64 and 49, Nimrod, how do we work out that angle there, just for the sake of completing the diagram? What do we do to work out this angle here? Someone work that angle out. What do we do?
That's 61, 49,
Okay, and then minus it from...
180.
Okay, let's do the calculation first. Let's do 180. Quickly do that for me, please. Minus 64 minus 49. Type in as you see on the board.
67.
That gives us an answer of
67.
67. Now, in order for us to use this formula, okay, we need to know what? We need to know this side here and this side, which we do. And we need to know this angle here, which we do. Because this formula works on the basis that you know the two adjacent sides. So we know this side and this side. Hang on a second, my little son's joining us. Shh, quiet. Let him make a video. Okay? So the A and the B corresponds, okay, not necessarily to our A and B. So what I'm going to do, I'm going to rub out their labeling and relabel the triangle. As I said to you before, make the labeling of the triangle suit us, suit our formula. So for the sake of argument, shh. Don't come back inside now. Right, let's get rid of this. A for the moment. So I'm going to draw the triangle. Now, half AB sin C. So the angle that you need is C. So this, I'm going to call this angle here big C. And this will be my little c. And I'm going to call this one my big A and my big B. So that's going to be my little a and that's going to be my little b. So far, it's really good. What do we know? We know from the formula, we don't know A, we do know B, and we do know that, and we know what the half, that's just a constant. So we need to work out the A. Okay? Now how do we work out the A? Now that we've got to the angle, we look for, we call it pairs. So, 49 degrees, that pairs up with, come again, yeah. Regina? Okay, sorry about that. Right. This 49 links with this one. That's one pair of information. Let's find another pair. Okay, we have, I call these dumbbells, okay, to join up together, make pairs. So do we know this pair completely? Yes. Isa, do we know this pair completely? And the answer is No, because we know the angle, but we don't know its side. So what rule do we use for that? When we have one complete dumbbell complete, so we know the side and we know the angle, that's one complete piece of information, corresponding angle and side. This one we know the angle, but we don't know the side. Which rule do we use? We use sine rule. That's it. Okay, we use sine rule. Okay, sine rule says we have A over sine of A is equal to B over sine of B. We only need to use the first two for the moment. Just start putting the values in straight away and rearrange it. So now A we leave as A, because we know what it is. The sine of A is the sine of 49 degrees is equal to B, which is 8.7, divided by its corresponding angle, the sin of 64. Okay, I'll stop there for a moment just to get you a chance to copy that down. Okay, Isa, do you know why we use sine rule? Okay, we use sine rule because we know one complete set of information, an angle and a side, one complete set. And the second set of information, we know this but we don't know that. So we know three things and we don't know one thing, three ticks and a cross. So in this particular situation, we use the sine rule. We have that kind of situation. Okay, if you look back at some of my older videos on YouTube, you find the rules on when we use sine rule, when we use cosine rule, and that'll give you more detail. Okay, but in this particular circumstance, we definitely use sine rule. Okay, now we're going to look at A. So Nimra, what do we do with the sine 49 on the bottom? I want to make A the subject. So how do I do that?
You take to the other side.
You take what to the side?
Okay.
You take the bottom, the fraction, the denominator. Opposite dividing by sin 49 is 2. So let's write that down again. Sin of 49 divided by sin of 64. Okay. Right, next calculator time. Grab your calculator. Tell me what you're waiting for. Throw it into the calculator. 8.7. Make sure you put a times in there as well, please. 8.7 times by sin of 49. On the bottom, use the fraction button as well on these new calculators. Very good.
7.3.
Okay, A is equal to 7.3. Okay, yeah. Isa, let's have a look at your calculation.
7.3.
Okay. Can you give me a bit more accuracy? What do you got? Let's have a look what your calculation says. 7.30531, yeah? Okay, leave that calculation in your calculator for the moment. I'm just going to double check that we got everything in view on the camera. MashaAllah we have, Alhamdulillah. Right, okie dokie folks. Are we happy with that so far? So what we've worked out the missing link. We need the A to use this area formula. Are we happy that we've got the A value? Don't touch the calculator because we're going to reuse that value, that exact value. So don't like press 0 or equal something or something daft. Right. Okay, let's move on back onto this formula now. This is the area formula. So let's start putting this value here, feed it back into there. So we say, okay, area is equal to half times by the A. A is equal to, for the sake of the screen here, the video, I'm just going to put 7.305. You're going to use the actual, your calculator display in your calculation. But for now, this will do for here. And then times it by B. What's our B value? The B value is 8.7. Times it by the sin of C, which is 67. Okay, right. Now that all the values are in place, we know the A now from that calculation. We already had the B, we already had the C. Throw everything into the calculator, please, folks. Take care with the calculator usage. Right, Nimra, have you already done that?
Yeah.
Okay, Nimra, what kind of answer you getting? I'm just looking at Isa's, what he's got for his. So Isa, what have you got for yours, Nimra? Have you put in yet? Come on, put in. Okay. So Nimra, what have you got for your one?
29.25191267.
Okay, right. And do you recycle that original value? Did you put that one back in, the original one? Okay, so let's have a look. So Nimra's saying we have area is equal to, say that number again please.
29.25
29.2
25 19
19
12
12 and so on, so on.
67.
Okay, right. It goes calculate the area of the triangle through 3 significant figures. Okay, Isa, do you have that similar number? Yeah?
Yeah.
Okay, so me got the same number? Good. Okay, so what we say, I'm going to change colour now. Area is equal to 3 significant figures. First significant figure, second, third. Okay, that is 5 or more, add 1. So it becomes 29.3. The area will be... Okay. The question was a bit long. Yeah? The question, we had to first of all think what formula we're going to use for the question. We have to go away and work out the A value, come back and then work out the area. Call these questions goal problems. Okay, it's a goal. So you've got to go and achieve something first in order for you to do the question. So you can't just straight away do the question, you've got to go and work something else at first. Okay? Are we happy with that? It's all done? Good? Okay, Isa, can you deliver to me the next question, please? Oops. Okay, right. Okay, we're nearly towards the end of the paper. I think we've got just one more question after this. Alhamdulillah. Okay. Right, Carolyn has 20 biscuits in a tin. She has 12 plain biscuits, 5 chocolate biscuits, 6 ginger biscuits. Oh, they're my favourite. I love the ginger biscuits. Okay. Carolyn takes at random 2 biscuits from the tin to work out the probability that 2 biscuits were not the same type. Okay, now, if we work out the probability of getting the 2 biscuits the same, and we minus it from 1, we'll get, this is the quickest way of working it out. So, work out the probability that 2 biscuits were not the same. So, probability of not the same for the calculation is 1 minus the probability that they are the same. So that's the opposite way of doing it. Now, because the probability of them being the same plus the probability of them being not the same will equal to 1. Okay, it's like the minus 1 rule. So let's work out the probability. To do this question here, we'll do it in reverse. We're going to work out the probability of getting the same biscuit twice. And then we're going to add that up and minus it from 1 to give us the actual answer they want us to work out. Okay? Right. What's the probability of getting a plane and the probability of getting another plane? Okay, first of all, how many biscuits are there altogether? 20. So probability of getting plane is going to be, first of all, is going to be 12 out of 20, and means? And means and. Times. And means time the probability. And what's probability of getting the second one? Now, remember she's taking 2 biscuits out, so is she putting the one back in again? No. So this is called without replacement. So what happens to the number of biscuits? If you have 20 biscuits in 10, you take one out, Isa, how many are left now? 19. So the next one's 19. So we had 12 biscuits first, we've taken one out. How many got left now? 11. Okay? That's the probability of getting 2 planes. 12 over 20 times by 11 over 19. We happy with that? Okay, now similarly, let's do now probability of the chocolate ones. Let's do a different color again. Change color. Okay, now we haven't worked that out yet. Can somebody give me a quick calculation for that? Give me a fraction, please. That gives us what?
33 over 95.
Happy with that, Isa? Got that too? Okay, now the next one, please. Let's work out the probability of getting a chocolate and the probability of getting a chocolate. The probability of getting chocolate biscuit is what? Chocolate biscuit is 5 out of 20. That's the first chocolate biscuit we take out. Now there's 19 biscuits in there. How many chocolate ones are left over? How many chocolate ones are left over? We're going from 5 to 4 out of 19. Okay, happy with that? Okay. So the probability for that should give us, is that 1 over 19 by any chance? Yes? Good. Right, next one. Isa, are you with me?
Yeah.
You happy with that? Okay, so you have the next one. Probability of a ginger biscuit. Ginger. Okay. My favorite biscuits. After that's chocolate digest, obviously. Okay. So what's the probability of me getting my first ginger biscuit?
3 over 20.
3 over 20. Okay. Smee, what's the probability of me getting my second ginger biscuit?
Is it 2 over 19?
2 over 19. And the total number of ginger biscuit probability is?
3 over 119.
Who says
Okay.
that?
Okay, right. Okay, what have you got there, calculation wise? Have you got, on the calculator, what have you got?
3 over 190.
3 over 190, okay. Okay, good. Now, as we said in the beginning, we can use this technique to work it out. So, here we go. For the last part, let's choose a red. So what was the probability of getting the same biscuit each time? This, or this, or this. When we use the word or, what does the word or mean in probability? It means add. So we're going to do 1 minus 33 over 95, and we're going to add 1 over 19, and we're going to add 3 over 190. I think that's correct. Okay folks, can you put that calculation into your calculator please, and tell me what kind of calculation you get out of that. Okay, try that. Okay. Okay, folks, have you got your answers?
Yeah.
What you got?
111 over 190.
Lovely. And what's the decimal version of that? If you press the SD button, what do you get?
0.584.
0.584 something. So we could say that would be 0.58 if you wanted to give it like a decimal equivalent. Okay, that's done. Lovely. Okay, are we moving to the last question now, Isa?
Yeah.
Done. Okay. Right, Isa, can you deliver us the next question, please? Right. Really nice one. Okay. Okay. OAB is a triangle. Now so topic is on vectors. O to A is a small vector A. O to B is a small vector B. Let's find A to B. Right. I don't want just the answer. Let's look at it. I need to go from here to here. Now, Isa, can I go at the moment? Can I go just straight up? And the answer is no, because we don't have the information to go straight up. The vector's missing, so we have to go the long way.
Yeah.
Okay, so I say I want to go from my area to another area, but I don't know the direct way, but I know a way through a different area. That's what we're going to do. We'll do the back streets. So we're going to go this way and then that way, following the vectors, the ones that we do know. Okay, so now if I go this way, which is opposite direction of A, what will that be then?
Minus A.
And if I go in the direction of B, that would be just normal B. Now let's have a look how we set it all out. So we say A to B, first we're going to go A to O. A to O plus, and then we're going to go from O to B. O to B, Now A to O is opposite of A, so that becomes minus A, and O to B is in direction of just plus B. Okay. Now we have minus A plus B. Some students like to just change it around and write down here there's B minus A. Whatever makes you happy, that doesn't make any difference to me. It's no problem. Okay. Okay. Okay, are you happy with that, Isa?
Yeah.
That's the first part of the question. So we wrote out A to B in terms of A and B. Because P is the point on AB such that A to P. Okay. No, Isa, actually don't do it back down to the moment because we need to see the vector. Do it back down, take it back down. We'll cope with the take it back to the measure. Up, same as stop. Lovely. Okay, that's okay at the moment. We believe it. Oh no, actually we're off the screen, aren't we?
Yeah.
It's over here. Okay. Oh,
You can
alright.
roll it on again.
Okay. Right, I'm going to read the next part of the question to you and then we're going to write it up there, the working out. Otherwise we're going to lose the diagram. Okay, right. It says P is the point on the subside A to P. I'll just rewrite it for you over here. Okay. So that's going to be, that's worth 3 parts and that's worth 1 part. What's 3 parts and 1 part? 4. So A to P is going to be 3/4, isn't it, of A to B. Okay, at the moment. And then P to B will be 1/4, 1 out of 4 parts. So we say that is 1/4 A to B. Okay. This here itself is not a vector. Okay, let's just tell you the direction. The vectors are these little ones here. But for the moment, these will do for us. For us to interpret the information they're giving us. They told us here that A to P, ratio P to B is 3:1. So that's worth 3 parts, that's worth 1 part, so we have 4 parts. So that's 3/4 of the way up, that's 1/4 of the way up. That's all so that's how we interpret this. So this 3:1 becomes 3/4 here, and becomes 1/4 there. Okay, that's how we interpret that. Okay, say they find O to P in terms of A and B. So we got to go from O to P. I'll do that. Where's my border bar? Yes. What? Okay. Let's find O to P. Yes. Oh. You got to work out that vector O to P. Right. Do we know? Do we have a vector for that at the moment? No. We got to work it out. We got to work out O to P. The actual vector there, we don't know what it is. Okay. Now, what do we know? We do know how to get from O to A. Is that right?
Yeah.
Do we know how to get from A to P? Yes, because that's 3/4 of A to B. We wrote A to B in the previous question. Okay, so we can go this way and then that way. Should we do that? So again, we're doing the long route. Because we don't know how to go from here to here directly, we got to go the scenic route. This way and then that way, and then the algebra, it will all simplify and give us the correct answer. So, let's have a look at that, Isa. Are you ready? Remember, we'll be reusing this. So let's write down what we're going to do first of all. We are going to go from O to P, and we're going to take the scenic route. Okay? That's not why I drive a scenic, by the way. This is the vectors almost. Okay, O to P, we're going to go from O to A, and then we're going to go from A to P. Right. As I said earlier, you remember I said to you earlier that that ratio 3:1 means 3/4 of the way?
Yeah.
So 3/4 of the vector AB. Okay? So under this part here, A to P, I'm going to rewrite now 3/4 of A, B. Are you happy with that, Isa?
Yeah.
What is O to A, Nimra? O to A is? A. So that's already vectorized now. Okay, now A to B. What is A to B? What is A to B? What's A to B, folks?
Minus
B minus
A.
A. Or minus A plus B.
Okay, B minus A. Okay. Most students get to this stage and they had enough. Oh no, I've got fractions, I've got to multiply negative letters. It's time to find the exit and run for the door. Okay, nothing to worry about here. Let's multiply out the brackets, simplify it, and inshallah, hopefully we should get the right answer. So, just rewrite over here. A plus A4 plus B minus A. Let's make sure, is that copied up correctly, folks? Yeah? Right, here we go. Right, so A stays the same. Now, what's 3/4 times by B? 3/4 B. If I say to 3/4 times by letter, it's just 3/4 B, just put them back together. What is plus 3/4 times by minus A?
Minus 3/4 A.
Minus 3/4 A. Now, we need to simplify. He saw I have 1A. 1A is made of how many quarters? 4. I have 4 quarters in there and I take away 3/4. So how many quarters do I have left over? 1. So this part here and this part here gives you, and that part stays as it is. Okay, happy with that? Now, could we factorize that and make it a bit more neater?
Yeah.
Take the quarter out. And we'll be running out of video space soon. So we say take the quarter out of the, as a common factor, and we're left with A
Plus 3B.
Okay, Lisa, let's have a quick look at yours. Are we happy with that? Okay, is that the last question?
Yep.
Any more?
No.
Okay, that's lovely. Okay, folks, sorry about this exam paper coming over into 4 videos rather than 3. We did have a battery failure in the beginning of the 3rd video, so that's why they had a 4th video. But that's all done now, so hopefully, I hope this helps you with your examination preparation. Remember, this is for the Edexcel 1 MAO, paper2H, okay, the calculator paper. This was the 6th of June 2012 paper, and inshallah, hopefully we'll see you in the next videos for the next paper. We're going to try a November paper next, which is a bit more, I call it a bit more juicy. The students don't like that word, they know it means a bit more harder. But no, it's just a little bit more kind of a challenging is the correct word. Inshallah, hopefully we'll see you in the next video on that. And until then, if you're going to break now for Salatul Asr, and inshallah we're going to pray. Assalamu alaikum, see you next week then.